tree. So first of all, we need to define what a transformation is. And a transformation is a rule that assigns to each point of a figure another point in the plane called its image. So you have your original figure, and then you have your image. Okay, the image is kind of like a second picture, okay, or a picture of the original item. And so let's go ahead and look at the first one, and that's what is known as a rigid transformation. A rigid transformation is also known as an isometry. Okay? A rigid transformation is a transformation that preserves size and shape. The image is congruent to the original figure. So that means the image doesn't get smaller or bigger. It stays the exact same as the original figure. And that's what is known as an isometry. It's also called a rigid transformation. And so there are three types of isometries. And those are the three we're going to look at today. There is a translation, a rotation, and a reflection. Now below that is just little pictures of what each of the individual ones are. We're going to look at them more in depth. And so if you just kind of want to hold on, you don't need to necessarily write those pictures down now because we're going to look at those individually. Okay, but those are what you need to remember: translation, rotation, and reflection. So the first one we're going to talk about is actually I take that back, we're going to talk about non-rigid transformation next. A non-rigid transformation is a transformation that does not preserve size and shape. The image is reduced or enlarged. Okay? It does not preserve size and shape. The image is reduced or enlarged. Okay? All right, so the first thing we're going to talk about is a translation. Okay? A translation is just what it sounds like. It's an isometry in which each point is moved by the same translation vector. You will hear a translation referred to as a slide. So you want to make sure you get down that last term, slide. Okay, because what that's going to do is if you associate a translation with a slide, that's going to kind of tell you what you do. And so there I have a total of 4 different translations. Okay. The first one is like a seashell, and basically all we've done with seashells, we've slid it, and we've moved it to a new place. Okay, there's a translation with patty paper. Okay, notice how all you've done is you've taken the patty paper and you've shifted it along that line. And then a translation on a coordinate grid. Basically, you're doing the same thing to X as you do to and then you do the same thing to Y for each individual point. Okay? So that's what a translation is. So we need to think of a translation as a slide. Yep. Okay, so let's go ahead and look at what we have next. Okay? Next, we have a rotation. A rotation is an isometry in which each point is moved by the same angle measure in the same direction along a circular path about a fixed point. The definition is way more wordy than what a rotation actually is. Basically, I like to think about rotations as a clock, something I can put on a clock. Okay, where the center of rotation would be where the clock hands are in the middle. Okay, and that's what a rotation is. It basically just moves around a circle. Notice a little bit about the shape. The shape does change in terms of orientation. Okay, so my original shape here, notice, it's different when it moves. It moves from horizontal to vertical, but it's still the same shape and size. Okay. Does anybody remember the third one that we had? Reflection, right. A reflection is an isometry in which every point and its image are on opposite sides and the same distance from a fixed line. And so if you notice in the diagram there, they have the line of reflection, which is a dashed line. Now I want you to think as you're writing that down, what would a reflection be similar to? Or what would be another way to describe a reflection? A mirror image. That's exactly what it is. So the image is mirrored. So let's refresh. We have what's the first one? Translation, rotation, reflection. Okay. We need to remember those. Translation, reflection, or rotation and reflection. All right, so now I've given you some patty paper. It says draw a polygon and a line of reflection next to it on a sheet of patty paper. So you can just draw any polygon. It doesn't have to be anything. It could be a square, it could be a rectangle, trapezoid, triangle. Okay, so go ahead and just draw a polygon. Now what I want you to do is draw a line of reflection. So the line of reflection, let's not have it touch the shape. Let's have it be a different line. It can be vertical, it can be horizontal, it can be diagonal. But go ahead and draw a line of reflection next to the figure you just drew. Once you do that, okay, once you draw in your line of reflection, what I want you to do is I want you to go ahead and fold your patty paper on that line of reflection. And then I want you to go ahead and trace the polygon image so that it's on the other side of the line. Okay? Okay. So once you've done that, what I want you to do is draw segments connecting each vertex with its image point. So basically, this is what you're going to do. Okay, this is a vertex point here. You're going to connect that, draw a segment to connect it to this side over here. Then you're going to draw one from here to here. Okay, so it's going to be to the mirror image. So if you have a four-sided figure, you should have 4 segments you drew in. Three-sided figure, 3 segments you drew in. So let's go ahead and look at this next statement. Okay. What do you notice about, as you drew those segments, and what do you notice about the line of reflection? The line of reflection is the blank of every segment joining a point in the original figure with its image. Think bisector. Perpendicular bisector. Okay? So it's actually the perpendicular bisector of every segment. Okay? All right. Okay, so let's go ahead and look at the next one. This is reflectional symmetry, which is also known as line symmetry. If you look at the blanket, okay, where would a line of symmetry be on that blanket? Down the middle. Would there be another one possibly?
If you cut it into thirds horizontally.
Horizontally would also be another one. So it is possible to have more than one line of symmetry. Okay. Rotational symmetry. These are examples of rotational symmetry. First of all, okay, remember with the rotational symmetry, you have your point of rotation. So the point of rotation here would be right smack dab in the middle. Okay, your point of rotation here would be once again in the middle. Okay, so you kind of need to think about rotational symmetry as a clock. And then, if you look at this next one, what is that? The figure below is A. What is that? A reflection, a rotation, or a translation? A, B, or C? Okay, B, nice job. Okay, it's a rotation because if you notice how the butterflies travel, it's like they're traveling around the edge of a clock. Let's look at the next one. What is that? Reflection, rotation, or translation? And the answer is a reflection. Nice job. Okay. All right, what about this one? And that one is a translation because it's similar to a slide. Okay, so reflection, rotation, and translation are what you need to remember today. Your assignment is found on pages 372 to 373. Okay, it's just 1 through 14. Okay, 372 through 373, 1 through 14.